Okay guys, so these are what notes we would be starting, well, we would have started this week. It's on right triangle trig. I know that some of you watched that video I posted the last time of just me working out some of the problems from your snow packet or emergency packet, whatever. But I want to walk through these with you. I posted a blank copy of them in the resource folder if you want to print them off and follow along. You obviously don't have to, but I feel like it would be beneficial if you can do that. So, it says to let theta, and that's how we say that little sign, let theta be an acute angle of a right triangle. The 6 trig functions of theta are defined as, and we have, these 3 are the main ones on the left. So, sine of theta, cosine theta, and tangent of theta. And then the other ones are cosecant, secant, and cotangent. If we have a triangle here and we put theta in the bottom right corner, it doesn't matter what corner it is in as long as it's one of these two, because this one's always your right angle and you can't have theta as the right angle. So we look at theta, the one directly across from it, that's the opposite side. The one on the bottom that's touching theta, that's going to be the adjacent. And the one across from the right angle is always the hypotenuse. Okay, so looking at this triangle, sine uses the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And if you can remember these, and remember in the last video if you watched it, I said SOHCAHTOA, and I think some of you have heard that before, and some people even remember it as some old hippie caught another hippie tripping on acid. So, So would be SOH for sine is opposite over hypotenuse. CA is CAH for cosine is adjacent over hypotenuse. And tangent is TOA, so its tangent is opposite over adjacent. If you remember those 3, then you should be able to remember these 3 because they are just the opposites of what they're across from. So cosecant is the opposite of sine, so it's just flipping the fraction. Same thing with secant and cosine and cotangent and tangent. So, and anytime if you need to pause this, I'm just trying to talk you through it, but pause the video and work out whatever you need to work out in order to understand it. But it says the ratios in the second column are reciprocals of the ratios in the first column. So remember, reciprocals are just where we flip it. Okay. Example 1, evaluate the trig functions of the angle theta. So here's what they give you. They give you a triangle with theta in the top corner, 5 and 12. So step 1 would be to find the third side. To do that, we're going to have to use the Pythagorean theorem. So that's right here. So remember, it's a squared plus b squared equals c squared. A and B are the legs of the triangle, and C is always the hypotenuse. So A and B are interchangeable, but C is always hypotenuse. Campbell's awake, so I might have to go get her. Okay, so we'll let 5 be A and 12 be B. So we have 5 squared plus 12 squared equals C squared. That gives us 25 plus 144 is C squared. So 169 is c squared. Remember, to get c by itself, we take the square root of both sides. And the square root of 169 is 13. So c is 13. Okay, so once we know c, we can put that over here. So c is 13. And then step 2 is to state the ratios and reduce when needed. So sine, we said sine was opposite over hypotenuse. So from theta, 12 is our opposite and 13 is the hypotenuse. Okay, so that's how we do that. Cosine is adjacent over hypotenuse, so that'd be 5 over 13. And then tangent is opposite over adjacent, so from theta, 12 is opposite, 5 is adjacent. So we get 12 over 5. To get the next 3, we just flip these. So this is 13 over 12, 13 over 5, and 5 over 12. That's example 1. Pause it as you need to. Okay, accidentally, let's see, can I move this? Okay, yeah. So example 2, it says in a right triangle, theta is an acute angle and sine is 4/7. Evaluate the other 5 trig functions of theta. So the first thing you want to do, they didn't give you this triangle, so we want to make one. So I draw my triangle, and I always just put theta in the bottom right corner. It's just how I always do it. It doesn't matter. So if we know sine is 4/7, we can go ahead and write that down. Okay, so sine uses opposite and hypotenuse. So from theta, the opposite is 4, and the hypotenuse is 7. That means we have to find the adjacent side. So to do that, we still use the Pythagorean theorem. 4 is either A or B, as long as 7 is C. So I used it as B. So we have A squared plus 4 squared equals 7 squared, which will give us A squared plus 16 is 49. Subtract 16 from both sides, you get 33. And so A is the square root of 33. You can't break that down, so we just leave it. So the adjacent side is the square root of 33. Okay, cosine. That's adjacent over hypotenuse. So again, adjacent is the square root of 33/7. Tangent is opposite over adjacent. So from theta, the opposite is 4, the adjacent is the square root of 33. So we have 4 over the square root of 33, but we cannot have a radical in the denominator, so we have to rationalize. So we just take that to the top and leave 33 on the bottom. Okay, so now we need to flip them and get these over here. Just put my screen back. Okay, so when we flip sine, we get 7/4. When we flip cosine, that's going to give us 7 over the square root of 33, but again, we have to rationalize. So it becomes 7 square root of 33/33. When you go to flip tangent and get cotangent, I would flip the first one, because if you flip the first one, then it's already automatically going to put the radical on the top. So it'll be the square root of 33/4. All right. Let's go to the next page. All right, so I want you to pause and take some time to try to do a couple of these. I already worked it out to where I know the third side. So if you do the Pythagorean theorem on 1, you'll get 5 as your hypotenuse. And as a brief note, on right triangles, there's special right triangles. And if you have a triangle that has the legs 3 and 4, the hypotenuse is always 5. That doesn't work for like 6, 7, 8 or anything like that. It's only 3, 4, 5. Okay, so if you look at this, theta's in the bottom left. So straight across from theta is 3. That's the opposite side. The one that touches theta at the bottom is adjacent. So 4 is adjacent. And the hypotenuse is always across from the right angle. So 5 is the hypotenuse. So knowing that, sine is opposite over hypotenuse. So you get 3/5. Cosine is adjacent over hypotenuse. So 4/5. And tangent is opposite over adjacent, which gives us 3/4. Finding the other 3, we just flip them. You should get those. Okay, so pause again. Try number 2. When you do the Pythagorean theorem, you should get 8 as your other side. So from theta, opposite is 15 because it's directly across from it. 8 touches it, so it's the adjacent. And 17 is across from the right angle, so it's the hypotenuse. So knowing that, filling out our trig functions, these are what you should get as your main 3. And then to get the next ones, we just flip them. So you should get this. All right. Number 3 is a different kind of special triangle. If you have 2 of the same sides, like if your legs are the same, so this is 5 and this is 5, which you don't know that's 5 yet, so if we didn't know. Okay, if this side is 5 and this side is 5 square root of 2, or like this side would be 4 and this would be 4 square root of 2, then this side is the same. So these are both 5, then it's 5 square root of 2. And then I'll show you, I think I have a triangle down at the bottom that looks like that. So knowing these sides, sine is 5/5 square root of 2 because it's opposite over hypotenuse. When you rationalize that, your 5's will cancel and you'll get the square root of 2/2. Okay, cosine is going to be the same thing because your sides are the same. Tangent is opposite over adjacent, so it'd be 5 over 5, which is 1. When you flip these, so if we were to flip this first fraction in sign, it'd be 5 square root of 2 over 5. Your 5s would cancel, and you'd get the square root of 2. Okay, because they're the same, like these two are the same, sine and cosine are the same, cosecant and secant are the same. And tangent, if you flip 5 over 5, it's just still 1. Remember, pause this if you need to. Okay, so it says, in a right triangle, theta is an acute angle and cosine is 7 over 10. Evaluate the other 5 trig functions of theta. So make your triangle. We know cosine is adjacent over hypotenuse. So adjacent's down here, so 7 over 10. When you do the Pythagorean theorem, which I have over here, so remember 10 is always c, or the hypotenuse is always c. So you get the square root of 51. And we're just going to leave it like that because there's nothing to reduce or factor out. Okay, I've got to go get Campbell. Hold on. Okay, so let's see, where were we? So we solved for the square root of 51. Sine is opposite over hypotenuse, so it'd be the square root of 51 over 10. So from theta, the opposite is the square root of 51. Hypotenuse is 10. And since it touches down here, it is 7 is the adjacent. So knowing that, cosine and tangent would be like this. Okay, when you go to flip these, this one becomes 10 over the square root of 51, but we need to rationalize. So we get 10 square root of 51 over 51. Okay, so when we flip this one, we get 10 over 7. And then this one is 7 over the square root of 51, which is just 7 square root of 51 over 51. Alright, it says that angles 30, 45, and 60 occur frequently in trig, and those are our special angles. Kind of like the brief video that I showed you, or that I linked for you earlier this week. And the little chart that I put under the resource folder, it's just like this. This one just has, actually no, it's just like this, I'm sure. Alright, so you can use either one, but fill this out. Okay, I'm going to have to do a part 2 video because they can only be 15 minutes and I don't want to get this started and then have to break. So I'll go ahead and pause part 1 and then we'll pick up with the second video here.